Well, welcome back, everybody. The reason why I said that is several months ago. It seems like several months, maybe 2 or 3 months. This was my very first video. I'm getting halfway through the repair, restoration, or what do you want to call it, for this guy. So I decided to try to finish it out today. The first video was called "What's in a Box." It wasn't very good. Watch it at your own risk. But basically at that point I replaced the power cord, cleaned up the front, took all the dials off. I actually took everything out and just cleaned everything. Replaced a few components, and that's really about it. I thought it was going to be quick and easy. I end up not having all the components I needed to replace. There are a handful of resistors in here that need to be changed out, and then the one capacitor I never got to, and that one needs to get changed out. There's actually only 4 capacitors in here, right? 1 electrolytic, 1 paper, and 2 micas. I left the micas in there. I haven't confirmed if they're good or bad or not, but I'm assuming that they're going to be good. But I did go ahead and replace the electrolytic. So it wasn't in that bad of shape when I got it cleaned up. It was pretty nasty when I got it. All the knobs are in a box, so if you're wondering where those are, I have them. And I replaced some of the hardware, some of the screws with stainless steel. I actually didn't order enough, so I need to go back to the hardware store and get more. So it's already unscrewed from the box. The box has a lid on it, and the lid hinges at the bottom, and you just slide it out and take it off, and you don't have to deal with the lid. So that's actually sitting on the floor, and what I'll do is I'll take it out of the box, get rid of the box. That way I can have full access to everything else. So there we go. We're going to lay it down. So this model, if I didn't mention, is a 600A Hickok tube tester. I was pretty happy when I got it. I was pretty proud of it. I'm still proud of it, but I was still pretty proud of it. And I kind of wish I would have bought a nicer shaped one starting out. And I'm finding that when I buy this stuff, it's a lot easier to work on something that is halfway decent shape than some of the basket cases that I've been buying. So future thought to myself, maybe wait for the deal, for a good deal to come up that's not a basket case. So there's a lot going on here. It has 2 tubes that sit right here. I have those out. We'll put them back in later on. And we got some capacitors to some resistors to replace, like this guy. There's a 1 meg sandwiched in here, I think, or maybe it's on this bottom one that I need to pull out. That one's good. And then we got all 3 of these. Let's see if I can get a better angle here. Something to point with. So I got this one, that one, and there's one right behind this one that I will replace. And other than that, I'm thinking that's it. And then we will put it back together, sort of, and then I will run through the calibration procedure as much as I can. It does call for a calibrated tube. I don't know what the hell that is. Don't know where you get one. I'll have to figure that out. But we'll get through. There's a handful of checks before you get to that point. that I'll attempt to do. I really could use this thing. Almost every project I work on, I'm always assuming the tubes are good, and the first issue I run into, I start thinking, is it the tube? Is it not? So long time overdue. So let's get to start replacing this stuff. Move this back a little bit. In fact, let me get situated here. I'll come back and I'll just film everything, me replacing everything. Kind of makes for a dry video, but why not? Kind of match the very first video, long and dry. Okay, I'll be right back. All right, went ahead and got me a drink and change out of my work shirt. And now I'm ready to get on with this. Oh, I need my glasses too. Some of these guys are wrapped in there so good that I don't always end up taking them all the way apart. Sometimes I'll just cut the wires off of them and go on. That didn't work. I have a couple of radios I like to start working on. I have worked on them off and on. And some of the tubes, I don't know how strong they are or how good they are. What ends up happening is it ends up causing a lot of doubt whether or not I'm going about it the right way. I like to use this little heat sink clamp thing here because I'm not too fast when I'm soldering, so I end up dumping a lot of heat into whatever I'm doing. I don't have the best soldering gun to begin with. Man, it's just not going. There it goes. When you go to Newark or DigiKey or Moser, if you look at the technical data for some of the components, I haven't seen it on every component. It'll actually tell you how long you can apply heat, how much of heat you can apply. And sometimes they say just 3 seconds. which I know I might be a little bit longer than that. Alright. So our very first resistor, wherever it went, not sure where it went. Don't matter. Let's go back to the so on here, damn it, pencil fell. Alright, so we'll just pull the schematic. So on here, we are looking for, we're down in this area right here. So if we go up, I believe we're looking for R15, R23, and R10. So I need 120,000, a 1 meg, and 120,000. Is that right? Yeah. I got my capacitors. This is 120K. And these, the ones that we just pulled out, have a tolerance of 5% at a half watt. The ones I have in my hand are half watt, 5%, so that will work. I always check them before I put them in there. Might be redundant, but yeah. Yeah, we're sitting about 118. Clean up this side a little bit better. There we go. Normally I would match these up how they're shaped when I pull them out together, but I don't know where the other one went, the old one. Thinking that will be fun. Nope. Alright, so we got this guy in there. You can see him right there. And this one right here needs also thread through that same hole. So that is a what is it? Brown, red, yellow. So I think that's 120. Yep. I still have to double check. Alright. So that should be my last 120. I think before I put that one in there, I might need that room. We have you're not going to be able to see it from this angle. So we have a 1 meg sandwiched in here, right in here. Before I do anything on the other side, I'm gonna get that guy out. Because I think that one is going to be a pain. I'm actually going to use this guy as a little clamp and just, well, I don't think I'm going to be able to get a hold of it. I'll have to do this one off camera, but y'all get what's going on here. All you're going to see to me is move around, and I'm going to shut the camera off and save some battery and try to get this damn thing out. Alright, got that thing in there. Lot more challenging than I wanted it to be, but it's done. So remember, we already put that in there. Gotta replace that one. And then this guy right here that's strung to right there. So since I already have this side cut out, I'm going to go ahead and get the other one wherever I just put it. That was a 1 meg. Don't think we need that. I think this is what I need right here. Yep. All right. So this guy's going to have to stretch pretty much from there to there. Yeah. Alright, so I rearranged the camera. I think it's at a better angle for everybody. So we replaced this guy right here already. It's not soldered in yet. I just have it wired in. And then this guy went to that bottom one as well. So I'm going to go ahead and get this guy in there. So 120K. So we'll end up putting, y'all can't see it. It don't matter. It's 120K. Man, I think I'm not a surgeon. Come on. This is what happens when you're just trying to go as fast as you can and not really think it through. As much as I want to be smooth on this stuff, it just doesn't happen that way. Way more flux on that top one than I wanted to. Alright. Okay. I think I can go ahead and cut all these out on the back end of there. So this guy, all these have to go. Oh, it's pretty loose. That went flying. Alright, so we got this 120. That's going to go on there. Like so. And then we'll have this 100 and, what is that, 50? I don't remember. I think that's 150. That will go on there next. But we also need to replace this guy. And I have it ready to go. And I already marked the foil side, negative side, however you want to call it, right? Just going off that line. So this guy went straight up in there. So I think that would be fine, just like that. Actually, I need to bend this guy out just a little bit more. Uh-oh, this little tab is messed up. Maybe I got too carried away and cutting it. Don't matter. We'll make the most out of it. All right. Now I need to go ahead and replace this guy, just to get everything laid out before I start soldering. Do this from the other side. Alright, what did I say, this was 150? Yeah, 150. One mag. That's not it. So I think that one was a half watt. What I have on me is a 1 watt. It'll be just fine. Sorry for my fat hands being in the way. I ended up taking too much of a curve in here. I took up too much material. Alright. This one I don't like at all. Because the little tab is broken, that hole, and it doesn't have a lot of that's what I'm looking for, integrity to it. Okay. I think that will be fine. Okay. All right. So, on my list here, I replaced this guy. This was the one that was sandwiched in between the switch, or in the rotary switch, and these three. And I have one more up here, which is a R25, and it is a 128 ohms. And what I normally do, so I don't forget, is I'll go through and I'll take a silver paint marker and I'll put a silver dot on the ones that need to be replaced, just so I have an easier time figuring out. And you can see right there, stay. That's the one. So I actually don't have 128, I have 130. So I went through the little package I had of 130 ohms, and this guy, even though it's 130, measures in at 128.2, which is perfect because the tolerance on this one is 1%. So that worked out pretty well. So what I'm going to do on this one is I'm going to actually cut this one out. And see if I can get this other one threaded through there. It's going to be challenging. I don't think so. Let's see what I can do. Alright, you can see that this was that resistor that was there, so that worked out pretty well. Measure this one, make sure I didn't grab the wrong one. I don't know about the rest of y'all, but buying components starts getting expensive after a while. I have so many different resistors. It's crazy. Going on with capacitors as well. Oh, how that one get off on it. Oh yeah, yeah, we are good. Do this backwards. Okay. I'm just going to string this one in there, thread this one in there just the way that other one was. I have to cut that one out. it's just not coming apart. I think what I'm going to do is get some shrink tubing. Put a little piece on there. I know that's hard for y'all to see. Okay. All right, so I have this in place. It's not pretty. Get out further. And of course, I dropped my solder. No, I didn't. Got it right here. Switch hands. Okay. You know what? I think that's it. I think we can, God, that is ugly. I could have done a better job. I'm too eager right now. I want to see this thing fire up or explode as long as something happens. So let me get the box back out. I'm going to put the tubes back in it, and we're going to plug it in and hope for the best. Okay, got it all here in the box. Have it plugged up. Don't have it turned on. I can already tell that the gauge is slightly off, maybe a 1/16 or 1/8 of an inch. We'll turn it on. Nothing smells funny. I don't hear any noises. Nothing sizzling, which is all great. We'll let it warm up for a moment. I went ahead and got some tubes, just to see if we can test one of them. See what else I got. So maybe we'll test this tube right here. This is a 12DT8. So let me turn this off real quick, and then I'll let that warm up. And the dog is calling me, so let me go let the dog out, and I'll be right back. Alright, that didn't take too long. So while I was letting the dog out, it's been sitting here warming up just for a couple of minutes. So if you never operated one of these, we're going to operate it together because I've never operated one of these. So I put in there, I don't remember what was in there, 12D-T8, 12 Delta Tango 8. So you're going to take the dial here, and you're going to find 12D-T8. And it's going to be, so it looks like there's two different tests. And all you do, right, you got your tube type, and then you have your filament, sectors, bias, English, and then you press, it'll tell you what button to press, giving you notations, right? So we're going to test triode number 1 and number 2, and mutual conductance we should be over 4,000, which 4,000 is right in here, right? So if I read that right. So let's back out so you can kind of see what I'm doing here. So the first thing I'm going to do is go to 12.6. I'm already on 12.6. I'm going to go to filament E, then V, 76608, and then I'm going to put it on 9. I'm going to put my bias to 10. Then I'm going to put my English to 85. And then I'm going to press P4. And we are not so good. I'm still in the green. But it doesn't look like I'm meeting the requirements unless those bottom numbers on the requirements. Now remember, I have not calibrated this at all. So who knows how far off or on or below we're going to be. So now I'm going to go test the other side. And nothing changes except for a few of the selections. So I need to turn it to 21. So that's 2, 1, 0, 3. I'm on 9. Same thing. These are the same. P4. See what we get. We're roughly a little bit less the same. So I think we ought to calibrate it as much as I can. I got the calibration procedure right here. And it's 2 pages. Nothing looks that difficult. But we're going to go ahead and calibrate it. Come back, test the exact same tube, and see if we made an improvement, made it worse, or it's exactly the same. So, a couple of things to notate on here is that these bulbs have to be exactly what it calls for, because they use the resistance in the bulb as part of the controls or calibration for the machine. And these are starting to get kind of hard to find in the right resistance. So if you get one of these things, make sure you go ahead and buy the bulbs. You just never know. So alright, let me get situated. I still got to take care of the dog. I'll be back, and we'll start testing this. Very exciting. So happy that this thing actually works, and I can use it for all these tubes and radials I got. So very exciting. Alright, I'll be back. Alright. So the very first check, it says check English and bias dials for indexing at 0 when set is on 0. Or indexing at 0 when set on 0. So we're going to turn these all the way down. That's right on 0. Yep. Y'all hear my dog? I don't understand what she wants. That one's actually a little bit off. Let me see if I can. Well, it's hard to see, but it is a little bit past 0. Let me go deal with this little dog. All right. All right. See if we can finish this out. So the very first thing it told us to do is set the 2 dials on 0 and make sure that they're actually lining up. This one is a little bit off. And it's still a little bit off. What's happening is when I turn it back, it's pulling it back, turning the shaft back a little bit. There we go. There we go. So step 1's done. Step 2, with the cathode and suppression switches in the same position, example 1133 through the range of the positions, and with the exception of the position number 2, or 2, the short test indication should show short when short selection switch is placed on 2 and 3. Okay, so we're going to put this on 1 and 1. Okay. Nothing on 0. I don't know if that means it's off. So we'll go to 3. Okay. Okay. If I did that right, I don't feel like I did that right, but if I did that right, number 2 is done. So just circle that. Alright, number 3. With the short test switch in tube test position, set the selector switches for this tube number, or information, JR53472, which is the same setting for a 6L6 tube for all the following tests. So, I think I was messing around and I went ahead and did that. So J, no I did not. Okay. JR 534 and 2. We're going to put that in tube test, right? Yep, tube test position. And now we go on to number 4. With the meter on AC, range leads attached to pin 2 and 7 of the octal socket. So 8-pin socket, which is that one. I'm assuming it's that one. These are both 8 pins. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Huh. Well, I'm going with that one. Where was it? With a meter on AC, range leads attached to pin 2 and 7 of the octal socket. Turn the filament switches through the range and check filament voltage. It doesn't give me a voltage for that. And I got these crappy leads, right? I mean, I could probably fit that down in there, but I'm not fitting that in there. So this is kind of hokey. All right, 2 and 7. So that's 1 and 2, and I think I will just make the best of it without shorting anything out. I mean, this is 2 and that's 8. That's going to be 7. If you're going to do this at home, make sure you have a better setup than me. So we technically did that. Alright, for number 5, push P7. Oh wait, we didn't finish that. So we have a little bit of voltage. I am on the 150 volt range. We go all the way to K. I think we're getting reverse. Let's try that on the other side. Alright, there we go. So we're on the 15 volt range and we're cooking about it's hard for me to even read it. We're sitting about 13.6. No, that's DC voltage. I'm on AC. 15 volts. I'm on 50 volts. Where am I? Alright. So I'm sitting about 12.77 volts, right? I think I'm going to do this a little bit different. I'm going to use a digital multimeter for this next step. That says with meter on AC, range and leads attached to pin 2 and 7 for the octal socket. I am assuming it's going to be that one. Turn the filament switches through the range and check filament voltage. So I'll go 2 and 7. .2. I have no idea what the if I'm just looking for 0 volts or voltage there. It doesn't tell me. So that one is suspect. Alright, so for the same test, or same arrangement, push P7 and vary line adjustment controls that the meter of the tester points to line test. Now place negative leads on the DC voltmeter in pin 8. So push P7. Alright, so we've gone through some of these checks already, right? English, number 2, number 3. We set the controls to mimic a 6L6 tube. And now with the AC meter on, with the meter on AC, which is that one, we're going to attach the pin 2 and 7 of the octal tube, which is right here. And these happen to fit in there, and I got them going to the meter. And we're going to go and check the filament voltages of the of this tube tester. So we're going to start at 0.6. Now I'm going to write these down. Here it is. So 0.6, we're at 624. 1.1, we're at 1.09. The reason why I'm writing them down is because I don't know what the tolerances is. So 1.5, we're at 1.4. So I'm going to go through here and just start marking these down. Maybe these are some of those resistors that were right on the line of being out of tolerance, and I let slide. Maybe that's what's going on. I'll have to go back and look at the schematic and see what we got. Okay. 3.2. That was actually 2.5, yeah, 3.2, right? 2.0, 2.5, 3.0, 4.3 is what? 4.35. So we got 5, 6.3, 7.5, 10, 12.6, 20, 25, 35, 50, 75, 117. Alright, so here we go. 5.28, 6.35, 7.4, 9.965, 12.25, 19.41, 25.6, 20. Okay, so I'll have to go back and do some research, but that was not that bad. So now I'm going to leave it just the way it is. And step 5, where push P7 right here, and vary line adjustment control that the needle tester points points to line test. So let's do that. It's not moving at all. Push P7 and vary line adjustment control that the needle tester points to line test. Got nothing. Okay. Plug one of these. Let me make sure that this is all set up correctly again. JR 53472. Okay. Oh, there it goes. So I think we are right on it. That was strange, but I'll take it. So we did half of that. Now place negative lead of DC voltmeter in pin 8 of the socket and the positive lead in pin 3. So we'll take that one out, and we'll take that one out. So place negative voltmeter in pin 8 which will be right here. And then end pin 3. 1, 2, 3. And if I go to oh, P4. Okay. And push P4. So I'm really getting nothing on here. So I think we're going to have to go back to a different way of doing this. So I think we're going to have to get out the vacuum tube, the VTVM. So let me move this up a little bit.